you stay happy and healthy, and then you drop dead. But that's not necessarily the best way to describe it. And the focus, I think, on this panel will be worldwide. So I'm going to start and ask people to talk about what they think are they're passionate about, what they're working on. It's sort of an elevator pitch. And I'll start with Jared. Do you want to go first?
Sure, happy to. We're developing a life management platform that's really being built on the concept of self-determination theory from a behavioral science perspective, enabled with AI, along with the social physics concepts that Sandy knows extremely well and wrote the book on, basically, as a means in which to change engagement. So deal with patients in the 99% of what they do on a daily basis to improve adherence, healthy outcomes, et cetera, within that particular system. As a secondary piece to that, which will ultimately become the primer, is we're building a new and novel technology stack using a federated data approach and federated AI in order to give you, the patient, the ability to control your data and to profit from it, whether that's the exchange of value, goods, money, whatever the case may be. So it's really about how do we put the hands of data back into the originator of the source. And as we think about that, we think about connecting all the different pieces so that we can create true innovation and true speed to innovation within healthcare.
Right. It should be emphasized that this is a worldwide effort. So starting with Australia and Indonesia and Mexico and UAE and places like that.
Right. So everything we do is global, and we start with the underserved patient populations in the various territories we go into. So we're partnering with the government of Australia. We have a partnership in Saudi Arabia, partnering in UAE, partnering in Taiwan, partnering in Spain.
And maybe so partnering with your country.
That's right.
Yes. And Edward, so you co-created Microsoft Research, you co-created Intellectual Ventures, and now you're...
Well, doing lots of different things, but I think for the purposes of this discussion, the good news is, compared to 10 years ago, everyone seems to realize the game isn't longevity, it's healthy longevity. The idea of living a long time and being unhealthy isn't so cool. But the way we look at it is we look at it as a problem of economics. You know, the things that are getting in the way, one, of course, we've talked about regulation and policy, being very risk adverse. Sometimes that has the unintended consequences of suppressing innovation. But I think the other big part of it is that the healthcare system today is intrinsically, it's just unsustainable because it doesn't generate economic wealth as it actually cures people. So when you cure people when they have polio or a childhood disease, you create an economic productivity for the next 60 years. Okay, it used to be only 20 years, but increasing that to 60 created trillions of dollars of economic productivity. Today, when you actually are helping someone live a little bit longer with a chronic disease, you actually create very little economic productivity, you create cost. And that means it's unsustainable. And the only way we're going to solve this is by shifting it toward productivity and health, which means earlier interventions and behavioral changes, which we cannot do without tapping things like social data, behavioral data, and really getting in people's face 24/7 as opposed to just when you visit the doctor. Now, why is this an interesting problem now? We've got 3 technologies that have shown up in the last 5 years that are transformative in this sense. One is AI. We're able to look at data across many different areas that look uncorrelated and start to reason about how they're actually relevant to each other. And everyone on this panel has worked on projects like that, showing that everything from social data to psychological engagement with other people improves health outcomes. But we do this on a very, very kind of single case basis. We have no infrastructure to do it broadly. AI can do that. Second, we have something called blockchain, which, okay, let's face it, it was reused for a lot of things that weren't very helpful, but it is an ideal situation to actually make data that is trustworthy and can actually give incentives that are fairly distributed to the people from whom you're extracting data. That's super important because right now we're just exiting a phase where we take 99% of people's data and take 100% of the value of it and give it to 0.1% of the people. That's not right. Okay, and the third technology that's arisen is modern cryptography, which now, and I think many people in governments don't seem to realize this, solves a privacy problem. That it is absolutely possible to keep your data all in one place, reason over it, including with things like AI and learning algorithms, and never move the data out of that place. It sounds magical, but it is possible to do, and we need to really re-engineer the policy frameworks to utilize that capability. Those three things put together will allow us to really transform the way we look at sustainable healthcare.
I think that's great. Yeah. So that's a really interesting thing. It's very synergistic with what Jared's talking about. I'm going to mispronounce your name. Apology. Ami, who is head of the American College of Cardiology, because heart attacks and cardiology problems are a good example of if you can get it early, the world is a lot better off for it. So please.
Oh, that's a perfect lead-in. Dr. Ami, Chief Innovation Officer at the American College of Cardiology, and thank you for having me today. So I'd like a show of hands to start. How many people here currently or have previously measured their heart rate, sleep, other things? Just keep your hands up. Look around at each other for a second. So you are the key to longevity. It turns out that for the majority of you, sorry to start on a negative note, cardiovascular disease is your #1 likely cause of death. And it turns out that if you actually want to achieve longevity, you just need to be in the highest tertile of cardiovascular health. And that will give you just shy of a decade, 8.7 more years of life, if you can just be in the highest third of cardiovascular health. But our healthcare system right now, we are the American College of Cardiology, but we're a global organization, 42 countries, including Central and South America, Middle East, North Africa, and Asia. And what we spend most of our time doing is tertiary care rather than preventive care, even though we all, including all of you who wear these things, have the data that can now allow us to use predictive analytics. We are now calling it AI, but really we've been in the field of predictive analytics for a long time to predict your potential risk. And then in fact tell you now with the use of AI, which one of those risk factors is most likely to influence your mortality, which is most likely to influence your quality of life. And then you can think about what that means for you. So we're really excited now at the American College of Cardiology to think globally about how do we take that data, both from individual patients who want to know more and get more data, but also from hospital systems. And this means we need to cross borders. We need to figure out how to cross borders with our data. So our focus is, one, moving from tertiary to prevention because we can do it. And number two is engaging both our patients, our health systems, but also our governments in how do we safely share that data and use it, because the solution exists. It's simply the process to get there is still a bit challenging. And so I'd love to talk more with anybody about that.
That's great. So the three of you really ought to spend a lot of time together because you're all doing the same thing. God bless you. Anurang, you're chief architect for Stanford Hospital Systems. Tell us about what Stanford's doing.
I'm chief enterprise architect, but I also have the data science team to translate a lot of work that we are at the feel like we're at the intersection of discovery, education, and clinical care. And that gives us a really rich environment. And then when you put it in the context of Stanford, where you have other disciplines like computer science, ethics, and those kinds of things, that gives you so what we've done is we've built a responsible AI lifecycle that uses that multidisciplinary structure to assess AI capabilities or build new AI capabilities, and then scale them in three ways. One is we want to actually use the technology and the solutions first, right, and provide care to our own patients. The second is, rather than just focusing on sick care, which I think Dr. Bhatt was kind of, we want patients to have access to a lot of this self-service capability so they can take care of themselves as well before, they get sick. And then the third is, our, tagline is you invent here, and then you share with the world. So we want to, whatever we are building, not only do we want to use in our own clinical setting, we want to make sure that the world has access to it. And we've been trying to be as open as possible, not just with sort of other academic medical centers, but also with vendors. We just gave a bunch of code and things for evaluating models, monitoring models to Epic, for example, to embed into their software. So that's kind of where we are right now.
That's great. Okay, so it sounds like you're moving to be interactive with all these people so that you're adding that layer of preventative to it. And Siva, so you are with TCS. You're the head of their global AI cloud offerings. And so you're actually going to be the one that builds most of this for most of the world. You want to tell us about that?
It's fascinating when you take a back seat and look at a ringside view of what's happening across industries, not just life sciences, healthcare, and the like. It's all about the value chains that are now being disrupted thanks to access to a lot of data sources which were earlier thought to be having to be structured and computationally accessible. But thanks to now the large language models, Gen AI and all that, all the unstructured data sets are as well available to you. So combining the power of structured and unstructured, going beyond just sequential compute and taking advantage of parallel compute, thanks to a lot of new chip technology coming in, we look at how to accelerate what can be done across value chains. Switching gears to life sciences and healthcare, which is one of our largest verticals globally, both in India and abroad as well. We play across the full value chain there, taking advantage of AI and data. So one is obviously drug discovery. We run a platform. We use it for various customers. We work on drug discovery for customers worldwide. And beyond that, when you come into the patient care or the consumer part of the business in terms of value chain of how you take care of patients, we play a broad role in the payer and provider spectrum as well. I can relate to everything that was said on stage so far because these are all nodes of activity that we have when we interact with our customers on a day in, day out basis.
Great. So this sounds like, we've got the power team here to sort of build this stuff out. So I'm going to go back through and sort of ask you, so Jared, what can you make use of the other things here? How are you going to work with them?
Yes.
What is it that people ought to take home and come up to you with and stuff like that?
Yeah, I mean, the first is we're all from different organizations. One of the biggest challenges in healthcare is there's an adversarial nature to it. But the outcome is about the patient. We have to kind of put down the adversarial nature of it and build a consortium that's for good. It's for not only ourselves and our companies, but it's for our friends and our family. And people should be able to get motivated behind that. And when we build that, we've got to build together. So if we're going to build some of these AI models that we're talking about, we're going to deploy them and we're going to build care systems of the future, right? Consider for a second, we're going to have a deficit of 11 million doctors by 2030. The underserved will be served less, right? This is a big problem. So we have to change the care model. We have to change the ability to diagnose quicker and earlier, to be more preventative in the care. Yet today, we do one thing that no other industry does. We are the second or first largest industry in the world. We spend $11 trillion a year on 0.01% of the engagement time, right? You go and you see your doctor, on average in your lifetime, 16 minutes in a given year. As Rent told us, there's 525,600 minutes in a year. If you do the division, that's 0.01% of the time. 99.99% of your time is spent doing everything else, loved ones, family, friends, sleeping, etc. We focus all of our energy on trying to change your behavior at that particular moment in time, when we actually need to take the health and the non-health data, combine it, and put it together with the family, the social networks as a means of deployment. And the new AI systems that have been created, the new technologies allow us to be able to do that and do it at a very personalized level.
Okay, Edward, what do you think?
I believe there's 3 levels to build. One with governments in particular and policy agile ones, which is one of the reasons I spent a lot of time in UAE. It's to build that, what I'll call data sharing layer, but it isn't sharing. It's using this new technology, proving out that it works, building an open stack that allows groups that have interesting information, including individuals, to allow it to be used for a purpose, and also to be fairly rewarded for that purpose. It's not a complex system to build, but someone's got to build it, spec it, and allow others to actually implement it. So that's the first level. The second one is to work with medical care facilities who want to pilot projects inside of this that have a measurable outcome that's interesting to policymakers. And we're looking actively at pilots of that kind, right? That will show that this infrastructure works, validate that it can produce an interesting result. And the third one is something I call the health value model. And maybe the way to think of it is, we are in an era of supercomputing. Supercomputing is creating some of the most valuable insights we've ever seen in history. But if you look at the top 10 codes that are run by supercomputers, healthcare value is not in any of them. The closest we get to healthcare value is doing molecular modeling, okay, for drug targets. It is not about looking at all the myriad pieces of data that are related to a human to find out how to optimize their health value for their future. We know from small projects that this is a very computationally tractable and interesting problem, but the supercomputers do not run them. So my last third challenge is, let's actually figure out ways we can take this immense supercomputing resource that we're developing. In fact, just in the last 1 month, there's been $1 trillion pledged to actually building more supercomputer resources. None of it right now is being allocated toward healthcare value. So let's go do that. Let's take some fraction of it and apply it to that. So those are my
Okay, guys,
projects.
you got your orders there. Okay. Ami, you want to?
Yeah. So, you know, I'm not a supercomputing person. I'm a cardiologist. I sit with you for those 16 minutes, and I hope that I can take excellent care of you and everything that's going on with you. And it turns out I can't, because my human brain can't take all the information that exists in healthcare today that is relevant specifically to you at this moment, put it together, and offer you the best version of care. And that's hard. That's hard for clinicians. That's moral injury. That's knowing that I can't do in 16 minutes what I really should be able to do without the use of AI. And this goes to structured and unstructured. Yes, structured data to tell me what you have, what your risks are. Unstructured to help me in my interaction with you. Unstructured to use generative AI to go and get the latest information and put it at my fingertips. And now I come in incredibly prepared for those 16 minutes. So I just want to speak to how grateful we are for the supercomputing that can do it. But then let's get to the data. Once you have those stacks of data, what do? And I just want to give you an example of why it's important. We have guidelines in cardiology. I can tell you what the next best thing is for you. What I don't know unless I have enough time, which again, 16 minutes, I don't, is does your insurance cover it? In a single payer system, which model of decreasing your cholesterol are we using? Are you able to travel to the place where I told you to go for that procedure? I don't know the drivers of health or the social determinants. I need those to be included when we're thinking about the supercomputing. So it's not just the medical data. We're appreciating that I don't know the life data about you. And if I don't know your life data, the likelihood that I can get you to the treatments that I have, never mind prevention, let's go to treatment now, is actually pretty low. And so for all those reasons, we in the clinical field need those stacks to include those drivers of health in addition to the technical specs that we need to provide our care.
Okay, so life data and, of course, social health data. Anurang, you want to?
Yeah, so I think, collaboration in my mind with these experts and innovators that we are sitting here at the table is a given. That's at the bottom. What we're trying to turn the page is, so far, we're using the experts who have very few of, they're actually the ones training these models, I feel, actually. And I know some of the general intelligence is happening automated, but we're using them to provide feedback. I think we want to turn the page where the models are serving the providers to make them more productive. I think that's kind of where I think we want to go.
Cool. Okay, so you want to take it home?
Sure. I think it's incredible that given all this new tech is out there, we're very close to looking at a very holistic 360-degree view of someone that we need to attend to. Now, we often talk in the digital world 10 years ago of the segment of one, hyper-personalized attention and care. I think when you look at a subject with emotive interest rather than just the transactional aspect of dealing with somebody, you get to collecting and connecting these disparate sources of data, like Amy said, structured, unstructured, and you connect the dots and figure out a more wholesome, a more holistic approach to treating what essentially is lack of health, or better, advocating methods to prevent disease in the long run. So I think it's up to us as to how we configure, calibrate, and use this technology to provide really customized new world outcomes to those that we care for.
Okay, great. So we've actually been incredibly efficient. We have 3 minutes left. Anybody want to go for it? Okay.
I just want to piggyback on some of the comments that were made. It's not let's build a consortium. Somebody needs to build it. We've already funded and have spun out and are creating a consortium with people that are on the stage here today to build exactly what Edward was talking about, to include non-healthcare data, which is a huge emphasis, so that we can do exactly what we just talked about on the cardiovascular side, but apply it across TAs. So if you want to be part of the consortium, the door's open, and we call on you to come join.
Okay, so talk to you, talk to Edward, talk to me too, but I'm just going to refer you to you two, right? Probably you, yeah?
Yeah. So if I can make a pledge and then a request, I really think that if we can take AI and bring it to all of those who provide health, and I'm going to use the phrase community health worker, but I really mean all of those who are responsible globally. Then when we say pioneering a healthier tomorrow, I just don't mean what I started with, right? All of us who are wearing a Whoop or an Oura ring, like that's not a healthier tomorrow for the globe. But I think if we can focus on AI for community health workers, if we can focus on getting knowledge there, if we can focus on getting data from there and giving it back to those communities, if we can use, I see our tech giants here at Philips, Siemens, GE, if we can use ultrasound in the community, anybody do a decent enough ultrasound to triage sick from not sick, I think that is a healthier tomorrow. So if anybody is working on that, we're going to work on it more, but I would ask you to work on it harder as well.
That's super, good.
I would kind of just digest it to AI to kind of improve the value, blockchain to share it with people, and the new cryptography technologies to protect them.
Okay, and you're going to build it, yeah?
Absolutely. Just want to remind everyone, quantum's round the corner, so it's only going to get bigger and better.
Okay, and we're going to work together at Stanford to make that happen.
Yeah, I mean,
right?
and I think I'll remind people is that this is, I think Dr. Bhatt said it really well. It's about making the providers more productive, actually, right? So, and if we can somehow bottle the knowledge that they have, somehow we can educate the next generation of doctors better, and just improve patient outcomes.
Great. Okay, guys, so you have your charge. Join the consortium. We can actually raise productivity, which we need to do, and of course, have better life for everybody. And I think that the community aspect is the most, to me, that's really the place where we can sort of begin to get in. That's sort of my passion too. So, okay, well, thank you all.